Welcome to This Explainer. I'm your host, and today we're cutting straight to the chase. We're diving specifically into Cambridge Biology 9700, Syllabus Section 10.1, Infectious Diseases. We're going to bypass all the fluff, break down exactly what examiners are secretly looking for, and show you how to secure those top-tier marks. So, let's jump right into this critical question. Why is evaluating evidence so difficult? Well, principal examiner reports consistently flag this exact area as a massive grade boundary risk. A lot of students walk into the exam room thinking a giant memory dump of pathogen life cycles is going to be enough, but then they completely freeze up when they hit a data analysis question. And the kicker is, you aren't just missing one single mark here, you're losing all those compounding marks that come from successfully evaluating the evidence sitting right in front of you.
It actually all boils down to one very specific number: 3. There are exactly 3 massive pitfalls highlighted in the examiner reports that routinely derail otherwise perfect exam papers. Year after year, globally, examiners are seeing the exact same careless errors.
Here they are. Number 1, slapping the wrong terminology onto the wrong context. Number 2, completely forgetting to check units, especially when you're dealing with practical data questions. And number 3, providing generic, non-specific answers. Look, if the exam stimulus gives you a case study about malaria, your answer absolutely must anchor directly to the Plasmodium pathogen and its specific transmission cycle. General biology just won't cut it.
All right, let's move into our first major area, the conceptual framework, or basically, how to think like an examiner.
To actually avoid those pitfalls, we have to shift our mindset from just memorizing biological facts to understanding the real assessment framework Cambridge uses. The secret here is that examiners are craving analytical depth, not superficial breadth. They prioritize logical, structured reasoning. They really don't want a brain dump of 10 random facts about tuberculosis. What they actually want is for you to systematically analyze the evidence to show exactly how, say, Mycobacterium bovis transmits through unpasteurized milk. Just look at this direct quote from the reports. Candidates who reference cross-topic connections achieve significantly higher marks. This proves that top-performing students have a connected, conceptual understanding that transfers seamlessly to completely unfamiliar contexts. If you can take the transmission of a pathogen from topic 10.1 and connect it to the immune response mechanisms from a completely different topic, your mark band is going to skyrocket. Mastery literally means taking fundamental principles and applying them to brand new scenarios.
Next up is the method mark strategy, which is all about earning points purely for your process. We're stepping into the procedural side of things now. Securing marks just for executing the right methodology is absolutely crucial. In just a second, I'm going to reveal a specific examiner clue that can flip a mediocre response right into a top band score. But to even spot that clue, you need a bulletproof problem-solving framework. You can't just start writing blindly when you face a complex infectious disease question. This is the ultimate deconstruct, solve, evaluate sequence. Think of it as your blueprint. First, deconstruct the question so you know exactly what they're actually asking. Second, extract the relevant data from the stimulus. That's the specific context we were talking about earlier. Third, select your analytical framework. And finally, execute your answer using clear notation and correct terminology. Following this sequence guarantees you're checking for reasonableness and making justified recommendations every single time.
Now, when you're dealing with practical investigations, this exact step-by-step execution is precisely what the mark scheme demands. Practical work is all about proving your experimental skills. You have to explicitly mention selecting the appropriate apparatus. You've got to show you can follow sequential instructions, make accurate observations, and record your data in suitable tables. And you want to know the ultimate discriminator for top students? It's explicitly identifying anomalies before you draw your evidence-based conclusions.
Since data interpretation is so critical in Biology 9700, this right here is your statistical arsenal. Memorize this mapping, and I promise you, you will never apply the wrong test again. If they ask you to compare the means of 2 sets of infection rate data, boom, you use the t-test. Dealing with categorical data, like the frequency of different transmission vectors, that's chi-squared. And if you're looking for a relationship between 2 continuous variables, you go straight for correlation tests. Moving right along to Section 3, the examiner alert, where we resolve the terminology trap once and for all. Okay, here is that massive examiner clue I teased earlier, pulled straight from the principal examiner reports. Candidates consistently confuse key terminology. Oh man, this is the classic trap. Even if your scientific reasoning is absolutely flawless, confusing your vocabulary is an instant cap on your mark band.
You could have executed that perfect sequence in your head, but if your hand accidentally writes antibody instead of antigen, or you mix up the vector with the pathogen itself in a life cycle question, the examiner literally has to penalize you.
So, what's the immediate fix? It's our golden strategy. Always, always define your terms right at the start of your extended answer. Whenever you introduce a critical biological concept about pathogens or transmission, just give it a brief definition. This instantly signals to the examiner that you have total mastery over the theoretical architecture of the syllabus, and it completely protects you from falling into that terminology trap. Let's look at Section 4, comparative analysis, where we pit a flawed answer against a perfect one.
Seeing this strategy in action is a real game changer. Notice how the flawed approach just generically lists facts about getting sick? It's superficial, but a perfect answer. It applies defined terms, like explicitly naming the Plasmodium parasite and the Anopheles vector to establish crystal-clear causal relationships in the transmission cycle. And crucially, every single point is anchored directly to the stimulus material provided in the question. That is exactly what analytical depth looks like. Whenever you're asked to evaluate the quality of evidence, use this exact four-step methodology to hit those higher-order assessment objectives. First, don't just look for similarities. You must identify similarities and differences. Second, actually write out comparative connectives, words like whereas, conversely, or however. Third, support every single comparison with hard evidence or data extracted directly from the provided tables. And fourth, synthesize everything to draw a firm conclusion on the relative importance of your findings. As we wrap up this explainer, make sure to screenshot these core takeaways. Remember to define your terms, anchor to the context, and trust that analytical framework. Actually, here's a great homework task for you. Create your own memory hack acronym for transmission factors. By making your own acronym for factors affecting infectious diseases, you give your brain a massive shortcut for rapid recall when the exam pressure hits. So you now know exactly how to logically structure your reasoning. But here's the final provocative piece of the puzzle. If you misinterpret a specific command word, this entire framework completely falls apart. Knowing the biology is literally only half the battle. Knowing whether the examiner wants you to describe, explain, or evaluate changes the whole shebang. So to ensure you never fall into that trap, make sure you subscribe to Ace the Exams for more explainers just like this one. Next time, we're going to be cracking those command words wide open. Keep analyzing, keep evaluating, and I'll see you on the next explainer.